Welcome to Honors Geometry, Lesson 1.4, where we talk about angles and a lot of things that happen with segments, very similar to with what we can do with angles. So let's get right at it. Okay, an angle is made up of two rays with a common endpoint. That common endpoint is called the vertex. So the vertex here is C. The two sides are rays. So when somebody asks you to find or name the sides of an angle, make sure you give me rays. Ray CA and ray CB. Now, when somebody asks you to name an angle, you can name it by its vertex. Okay, in the book, the angle symbol kind of looks like a less than. So when I write angle symbol, I put a little arc in it to let you know that that is not an angle symbol. Sorry, it's not a less than symbol, it's an angle symbol. So you can name it by its vertex, angle C. You could name it using three letters. Okay, one point on the side, A, then the vertex, and then a point on the other side, B. Angle ACB. Going in reverse order, you could say angle BCA. Okay, that dinging you hear in the background is my wife eating cereal. That right there is angle C. Notice that the middle letter when you name it with three letters is a C. Sorry, is the vertex. And also angle 2 is another name we could name for it by having a number on the interior of that angle. That's how you name angles. However, we have to be careful when we are naming those angles because of the following scenario. Alright, go ahead and pause it. No, you don't need to pause it, but after I'm done saying it, you should probably. If there's more than one angle at a single vertex, you always use three letters to name an angle. Never use just one letter. So here we have several angles that have vertex O. So we have to use three letters. Angle BOC, angle COD, the two smaller angles, and the big angle, angle BOD. So if you just said angle O, I would ask you, which angle O are you talking about? Because there's three of them there. You got this angle here, you got this angle here, and you got the whole big angle there. Yes. Okay. Did I make that point clear enough for you? I don't know. You'll probably still forget this one. Okay, degree and measure. A degree is a unit to measure angles. If the measure of angle XYZ is 40 degrees, then write M, angle symbol, XYZ equals 40. This M stands for the word measure. So, okay, right. There are other ways to measure angles also. You can measure angles, well, you'll learn in trig class later on that you can measure angles in radians. And 1 degree equals pi over 180. Yeah, you'll learn more about that when you get to trig, so not much more of that. Another way to name angles or to measure angles is called gradients, and that is a right angle has a measure of not 90 degrees. It has a measure of 100 gradients, and they sometimes use that in construction of things, but we will use degrees in this class. So let's go ahead and talk about the different angles. Never mind, not yet. Okay, the angle addition postulate Remember, postulate we've already covered. Remember we had a segment addition postulate? Okay, this is the angle addition postulate. If L is in the interior of angle CAM, okay, here's angle CAM, L is on the inside, it's in the interior of angle CAM, then the measure of angle CAL, wait a minute, there's the ray, the measure of angle CAL, the first angle, plus the measure of the second angle, LAM, equals the measure of the whole angle, CAM. And that's a lot like the segment addition postulate. If you remember, with the segment addition postulate, we had a segment and a point somewhere between the two endpoints, x, y, and z. We said that the first segment, or the first part, plus the second part, oops, no symbol there, plus the second part, yz, equals the whole thing, xz. This angle addition postulate, pretty much the same thing. The first angle plus the second angle equals the measure of the whole angle. Let's move along. Classifying angles. An acute angle is less than 90 degrees. A right angle equals 90 degrees. An obtuse angle is greater than 90 and less than 180. A straight angle equals 180 degrees. And a reflex angle is greater than 180 degrees. So right now I've got a 0 degree angle right there. So this is an acute angle, it's less than 90. Okay, when that thing clicks into place, that's a 90 degree angle. Do you see that click in? That's 90. This would be obtuse until we get down to where it clicks into horizontal. That's obtuse. And then when you go beyond that, that would be a reflex angle. Of course, a reflex angle can look a lot like an obtuse angle. You would look at this angle and say, look, this is an obtuse angle here, but this outside part is called a reflex angle. And if you rotate all the way around, that 0 degree angle that I started with can also look like a 360 degree angle. And in trig class, you will actually talk about having it rotate around a bunch of times. But that's trig class, so let's move on. Hey, do you guys know how to measure angles? I have no idea. So I'm going to teach you how. First thing you do is you find the crosshairs of this protractor right here, and you put that on the vertex right there. Then rotate it so that you line it up with a 0. And it doesn't matter which 0 you line it up with, but line it up with a 0. Boom. Then you use that, starting with a 0 scale, to measure it. 10, 20, 30, 40, 50. Okay, it's between 50 and 60. Go out on the outside scale. The 55 is the really thick, long one, because every 5 it's got one of those long ones, and it looks like it's one tick over. That would be 56 degrees. If you lined it up with the other 0, then you would be using the outside scale, and we would again see that it's 0's on the outside now. 10, 20, 30, 40, 50. It's one tick past the 55. It's 56 degrees. And here is where you may commit intellectual suicide, because you may measure this thing out and then you might tell me that the angle is 125 degrees instead of 55 or 56 degrees, even though it is definitely an acute angle. So pay attention. Don't just put a number down because you want to put a number down. Pay attention to what you're doing. Okay, let's do it again. Put the crosshairs right on the vertex. Rotate that protractor. The 0 is lined up on the inside. and 10, 20, 30, 40, 50, 60, 80. That's not quite 90. I'm going to call that angle an 89-degree angle. Moving right along, let's do one more. Put the crosshairs right on the vertex. Rotate it to hit the 0. 10, 20, 30, 40, 50, all the way past 110. It looks like it's one degree less than 120. 119 degrees. Pretty cool, huh? And the last thing we're going to talk about, angle bisectors and congruent angles. Let's review a segment bisector, which is called a midpoint. A midpoint will divide a segment into two congruent parts. Q is the midpoint. How do we know it's the midpoint? Because of the tick marks here that show us that PQ is congruent to QR because of the single tick marks. That shows you that those segments are congruent. Well, we can do the same thing with angles. Here we have arc marks, and sometimes you will see those arc marks drawn like that, and sometimes you'll put single tick marks like that. Some teachers do that. I don't do that. Instead of doing that, I will put double arcs for different angles. So angle SET is congruent to angle TEV because they both have single arc marks. So that means that ray ET found home is the angle bisector because it cuts angle SEV into two congruent parts. That's all I have for you. This will conclude Honors Geometry Lesson 1.4, all about angles.